9.10, day 3, is going to seem similar to what we just did last night with the small story problems. And a lot of these will have an angle of elevation or depression, not all of them. So we're just going to see, they're all individual examples. We do have, I think, 5 of them to do in this intro video. So just stick with me, we'll get through them. But written in right here, it says draw a picture. You got to figure out where the right triangle goes. Then we use our trig ratio equation and solve. So number 1, a 20-foot ladder is leaning against a wall. So let's go ahead and draw. Here's a 20-foot ladder right there leaning against the wall. The base of the ladder is 3 feet from the wall. So here's the base of the ladder. Here's the wall over here. That's 3 feet in between there. What angle does the ladder make with the ground? So here's the ladder with the ground. That's theta. We have to figure out what that angle measure is. So we label the 3 sides of our triangle all according to this angle right here. You can see it's a right triangle. We have the opposite side, the hypotenuse, and then the adjacent. So we are going to work with the hypotenuse and the adjacent. So SOHCAHTOA, which one uses the hypotenuse and the adjacent? And that is going to be cosine. So we just write cosine of our angle theta, which we don't know, is equal to the adjacent side, which is 3, over the hypotenuse, 20. All right, so just remember we saw this in the last lesson. If you're trying to find the angle measure, you bring in your inverse. So we're going to say inverse cosine of 3 over 20. And then you go to your calculator, second cosine, see if we get the same thing. 81, so theta is equal to, we'll round to the nearest tenth, 81.4 degrees. All right, example 2. How tall is a bridge if a 6-foot tall person standing 100 feet away can see the top of the bridge at an angle of 30 degrees to the horizon? So what are we even talking about here? Well, first of all, we have a person and we have a bridge, right? So here's our person. There's my ringtone. We've got a bridge over here. So whatever the bridge might look like. You know, it's one of those tall bridges, maybe like Mackinac or something, you know, like that. And so how tall is a bridge? That's what we want to figure out. If a 6-foot tall person standing 100 feet away, so we are 100 feet away from the bridge. And then we're talking about the person can see the top of the bridge at an angle of 30 degrees to the horizon. So here's our 6-foot tall person. Here is the horizon, and here's the angle to the top of the bridge. So this is 30 degrees right there. We know that this person is 6 feet tall, right? So if I kind of go over here, I know that this is 6 feet, and we need to know the height of the entire bridge from here all the way to the top. So we have a way to figure out the top part of the bridge without the 6 feet, and then we can get our final answer in the end. So the 100 feet from the person to the bridge will go up here as well. That's 100 feet. And we're talking about a 30-degree angle, so let's focus everything on this angle. You have your opposite side. So do you guys see the triangle we're looking at? Here's the triangle we're going to use. Opposite of the 30 is where X is. Our hypotenuse is over here, and this is the adjacent side. So we are using opposite and adjacent. So if you go through SOHCAHTOA, you're going to find tangent uses the opposite and adjacent. So we know our angle is 30 degrees. So tangent of 30 degrees is equal to the opposite side, X, over the adjacent side, 100. Now to solve this, go ahead and make that a fraction so you can cross multiply. Start with the X. X times 1 is X is equal to 100 times the tangent of 30. And always put that number out in front of the sine, cosine, or tangent. So to solve this, all we have to do is figure out what the tangent of 30 is. So on your calculator, tangent of 30 rounded to 4 decimal places, 0.5773. And then we're going to take that and multiply it by 100. So 57.7, around to the nearest tenth for that answer. So 57.7 feet is what x equals. So if we go back to our picture, that's just this measurement right here, this height from here to here is 66 or 57.7? Can't remember. 57.7. So that is 57.7. We want to know the entire bridge, so all we do is we take our 57.7 and we're going to add in the rest of the bridge, that's 6 feet. We couldn't include the 6 feet because the angle of elevation came from his eyesight, so we had to use a higher up triangle. But we can backtrack in the end and go ahead and get that answer. 57.7 plus 6 gives us a total of 63.7 feet tall. That's how tall the bridge is. All right, example 3, an Air Force pilot must descend 1,500 feet over a distance of 9,000 feet to land smoothly on an aircraft carrier. What is the plane's angle of descent? All right, so we've got our airplane again. And the airplane, because it must descend 1,500 feet, that's telling you that's how high up it is. So it is at an altitude of 1,500 feet. It's got 9,000 feet to make this safe descent. So there's 9,000 feet. And then it's going to land on an aircraft carrier over here. So here's the plane's pathway. It's going to go from here all the way down. And we have to figure out what the plane's angle of descent is. Now remember, an angle of descent is the same thing as depression, angle of depression. An angle of depression is from the ceiling down. So from the plane, we have to get a horizontal line going. We need the horizontal. Then from here down, that is the angle of depression. That's what we don't know. That's theta. Now, that's not inside our triangle, but remember, if that's theta because of parallel lines with a transversal cutting through, we have this angle down here is going to be its alternate interior angle, which will be congruent. So now we've got an angle inside the triangle. So let's label our sides. We have the opposite side over here at 15, the hypotenuse, which is not labeled, so we don't even need it. But the third side is the adjacent side. So is it so, ka, or toa that uses the opposite side and the adjacent side? And this is going to be tangent. So tangent of our angle theta is equal to the opposite side, 1,500, over the adjacent side, 9,000. So anytime that you need an angle measure, we bring in those inverse functions. So inverse tangent of 1,500 over 9,000 is going to give us our angle measure. So on your calculator, go ahead and type in second tangent, and then we've got the 1,500 divided by the 9,000 in those parentheses. And we get rounded to the nearest tenth, we'll say 9.5 degrees. That is our angle of descent for the airplane. Example 4. An eagle spotted a mouse 20 feet below at an angle of 42 degrees with the horizon. If the eagle flies along its line of sight, how far will it have to fly to reach its prey? All right, so we've got an eagle flying in the sky. Oops. Pretend that's an eagle off in the distance, so that's what it looks like to us. And then we've got our ground, and we've got this little mouse down here. something like that. So what's happening is the eagle spotted the mouse 20 feet below. So that 20 feet below is a little bit tricky. What we're saying is that that's how high up the eagle is flying. So the eagle is 20 feet above the ground. It doesn't mean that it's 20 feet from the mouse. That's actually what we're trying to figure out. So an eagle spotted a mouse 20 feet below at an angle of 42 degrees with the horizon. So here's the eagle spotting the mouse. It says, oh, there's my lunch right there. And an angle of 42 degrees with the horizon. So from the eagle, we have to put in that horizon again. And then if the angle is 42 degrees with the horizon, that's our angle of depression right here. That is 42. Well, remember your alternate interior angles will tell you that this inside our triangle is 42 degrees also. So that's how that helps us out. And then the question is, how far will it have to fly to reach its prey? So what's the eagle's flying from here all the way down to the mouse? So that is X. That's what we don't know. So looking at our triangle, here's our 42 degree angle. We're going to label our three sides. The opposite side is 20. The hypotenuse is X, and the other side is the adjacent side, which we will not be using. So we're going to use the opposite side and the hypotenuse. So is it so, ka, or toa that uses the opposite and the hypotenuse? And you guys know it's going to be the sine. So we say sine of our angle 42 degrees is equal to the opposite, which is 20, over the hypotenuse, which is X. So when we've been solving these, we go ahead and put a 1 underneath the sine of 42. That lets us cross multiply easily. X times the sine of 42 is X times the sine of 42 equals 1 times 20. And then now we're just going to use our calculator to figure out what the sine of 42 is. So it's X times the sine of 42 rounded to 4 decimal places is 0.6691 equals 20. And then we solve, we divide both sides by the 0.6691, divide by 0.6691, that cancels. So X equals, on your calculator you type in 20 divided by 0.6691 equals, we'll round to the nearest tenth, so 13.4. And then what are we talking, 13.4 feet. Which does not seem correct at all. Are you guys double checking my work? Because I think there's a mistake. So pause the video and see if you can find it. Because I'm going to pause and see if I can find it. First of all, let me tell you why I think this is incorrect. Here's what I noticed. And these are the kind of things you can notice. I said that X equals 13.4. And so I thought about the triangle that we started with. That's the hypotenuse, 13.4. Well, the hypotenuse of your triangle is going to be the longest side of your triangle. Well, this side is 20, so there's no way that the hypotenuse can be shorter than 20 feet. So that was what caught my eye. So pause the video, see if you can find the mistake. I'm going to find the mistake here in a second, and we will fix this. All right, I have paused, and here I'm back again. Did you guys figure out what it is? If you are using your own calculator and following along, you would have noticed that when you did 20 divided by 0.6691, it did not equal 13.4. I accidentally multiplied those. I hit the multiplication button instead of the division button. So actually when you divide, like you guys did, you're going to get 29.9 feet. But that's just a good example of being able to catch something that you know can't be right before you turn in a quiz or test or working on your homework or something like that. All right, last example of this whole chapter, right? That's kind of cool. All right, so in a movie theater 100 feet long, the floor is sloped so that there is a difference of 30 feet between the front and back of the theater. What is the angle of elevation? So we had one kind of like this in another night's video. So, you know, you got this big movie screen at the front of the movie theater, and they're saying that the movie theater is 150 feet long. So here it's 150 feet to the back of the theater. The floor is sloped, so you know how you have to walk up to get to higher rows, so it's sloped up like this from the screen. And there's a difference of 30 feet between the front and back. So you're saying that this is 30 feet up compared to down here, it's just at 0. So that is 30 feet. What is the angle of elevation? So angle of elevation is going to be from the ceiling, or sorry, from the ground up, because it elevates up. So down on the bottom, here is our ground, and then we are elevating up to that angle right there, or creating that angle. So this is our angle of elevation, so theta is right there. All right, so we're going to label everything in terms of this angle, starting with the opposite side over here at 30. We've got our hypotenuse, which you can see we're not going to use, and the adjacent side. So you guys are probably getting pretty familiar with the opposite and adjacent side being your tangent function. So we're just going to set that up. Tangent of our angle theta is equal to the opposite side 30 over the adjacent side 150. Now again, anytime you're trying to find an angle, you bring in the inverse tan. So inverse tan of 30 over 150. That's a 0 down here. Kind of hard to tell. And then you go to your calculator. You do second tangent, type in 30 divided by 150 in parentheses, and we're getting 11.3 degrees for our angle of elevation.